Hey everyone, welcome to this explainer. Today we're basically putting on our chief architect hats to unpack the Day 26 system design notes. This is a total masterclass, entirely focused on the nitty-gritty mechanics of scaling large systems. 10 million plus, to put that into perspective, that's roughly the entire population of Sweden hitting your app all at the exact same time. It's wild. Everything we're covering today is about building an architecture capable of actually supporting that massive concurrent user base without crashing and burning. So here's our blueprint for today. We'll be hitting 1. The 10 million user challenge. 2. Approaches to server scaling. 3. Managing traffic and loads. 4. Database and data flow. And finally, 5. Achieving global architecture. Let's just dive right in. Section 1. The 10 million user challenge, setting the ultimate design goal. Because look, you can't just flip a magic switch and suddenly handle 10 million users, right? It requires a very deliberate, multi-layered paradigm shift in your infrastructure. Every single concept we cover today is a direct answer to tackling this overarching challenge.
Moving to Section 2, Approaches to Server Scaling, Building the Foundation.
Okay, we start with vertical scaling. This is essentially just throwing a faster CPU or a bunch more RAM at your existing machine. Now, it's the simplest fix, sure, because it requires zero architectural changes. But you already know the fatal flaw here. Hardware has a hard ceiling, and having one massive server is frankly a terrifying single point of failure. And that brings us to horizontal scaling. Instead of relying on one ultra-expensive supercomputer, we pool together a bunch of standard servers. When one gets overwhelmed, boom, we just add another. This unlocks theoretically infinite scalability for our 10 million users, but it definitely introduces entirely new headaches, like network latency and keeping track of state management. But as we actually approach that 10 million user mark, we have to ask ourselves a really vital question. How on earth will our horizontally scaled servers adapt when user traffic suddenly skyrockets? Imagine a massive celebrity tweeting about your app. You need capacity instantly. But on the flip side, you certainly don't want to pay for 1,000 idle servers when traffic drops back down at night, right? So this perfectly illustrates the absolute necessity of auto-scaling. It dynamically grows or shrinks our fleet based on thresholds like CPU usage without needing to wake you up at 2 a.m. It essentially perfects load management and shuts down those idle instances so you aren't just burning cash when traffic normalizes. All right, Section 3. Managing traffic and loads. Directing the flow. Enter load balancing. Sitting right there in front of your server farm, it acts like a traffic cop, distributing the immense pressure of millions of incoming requests. Whether you're using round-robin or least connections algorithms, it ensures no single server gets absolutely crushed while others just sit there twiddling their thumbs. Let's do a quick recap of our toolkit so far. We upgrade vertically, we expand horizontally, we adjust dynamically with autoscaling, and we route everything efficiently with load balancing. These 4 pillars work seamlessly together to make sure our front-end architecture never collapses under the weight. On to Section 4, Database and Data Flow, Preventing Data Bottlenecks. So application servers are kind of the easy part, right? Because they're stateless. Database scaling is where architectures truly start to break. To actually handle 10 million active connections, we have to move way beyond a single, overworked database. We do this by separating our read and write operations, or by sharding the data across multiple servers. And to protect those databases, we rely heavily on caching. By storing frequently accessed data, like, say, a global leaderboard, in blazing fast temporary memory, we serve our users instantly and save our databases from doing the same repetitive queries over and over. Now, obviously, this introduces cache invalidation, which is famously one of the hardest problems in computer science, but the speed trade-off, it's absolutely mandatory at this scale. Now, for the heavy, time-consuming tasks, like processing a massive batch of video uploads, we use message queues. By decoupling these asynchronous background tasks from the main user request, our worker servers can process the queue at their own pace. And the best part? It doesn't freeze the user's live experience. So this powerful trinity, database scaling, caching, and queues, it ensures that data flows smoothly, reads are virtually instantaneous, and heavy processing never bogs down the front end, no matter how big the system gets. Section 5. Achieving global architecture, taking the system worldwide. First up here, we leverage a CDN, or Content Delivery Network. By pushing static assets, like images and JavaScript code, out to edge servers geographically closer to the user, A user in Tokyo downloads assets from Japan, not from your primary servers sitting in New York. The latency savings there are absolutely massive. And finally, for true global dominance, we use multi-region architecture. Basically, we replicate our entire stack across different continents. Not only does this heavily optimize routing for global users, but it acts as the ultimate disaster recovery plan. Literally, if an entire data center drops offline, traffic is just seamlessly routed to another region. Look at how beautifully these architectural layers just stack together. We scale the servers, we manage the incoming traffic, we optimize the data layer, and then we push the whole thing global. It provides this crystal clear, step-by-step masterclass to solving the 10 million user challenge. So now that you have the complete theoretical toolkit for scaling massive systems, the real question I want to leave you with is this. Where exactly would your current application break first if a million users logged in right now? Think about it, because every app has unique bottlenecks. Thank you so much for joining me for this explainer. Keep building, keep scaling, and I'll catch